Hello and welcome to our program, Astronomy for Everyone. In our program last month, we talked about buying and using telescopes for both the beginner and the intermediate observer. This month, we're going to continue that and talk about telescopes for the advanced observer. With me here in the studio tonight is Doug Bauer, president of the Ford Amateur Astronomy Club, and Ken Anderson, also a member of the Ford Club. Gentlemen, welcome to the program.
Thanks, Don.
Thank you. Well, glad to be here.
Well, we've got several different types of telescopes to talk about tonight, and there are three basic styles that, or types that are involved in amateur astronomy. We have the refractor, the type that uses lenses, the reflector, the one that uses mirrors, and a combination telescope, typically represented by a style called the Schmidt-Cassegrain. Now, we don't have one of those specifically with us tonight, but we do have a hybrid type of telescope that falls into that category, and it's the one right behind me here. This is actually a variation of a Newtonian telescope. It's a Schmidt-Newtonian. That's because we have the corrector lens up front. This helps correct for spherical aberrations such as coma, stretching out of stars and making them look oblong. This particular telescope has an 8-inch diameter, which you can see right across here. The focal length is 800 millimeters, which gives it an effective F rating of F4. Now, this is also a computerized telescope. Down here I have my hand controller, which contains a small computer that has thousands of objects that I can observe with by just punching in either its designation or the coordinates. All of this is powered by a battery pack that I take along with me out into the field. Typically, there's not a 110 outlet available out in the middle of an observing field. So I have that to power both the motor for the telescope as well as the computer and the dew heaters that help keep dew from forming on the optics, such as the mirror up here and on the eyepiece. Now, this is a small scope in the advanced range. Some of these telescopes can head upwards of 14 to 16 inches in diameter. And this telescope right here ran me about $1,300, to give you an idea of price, which is one of the 3 Ps that we've been talking about in this particular series. The performance is really quite nice. It has some advanced coatings on the mirrors that enhance the reflectivity and make for sharper, clearer images. And as far as portability is concerned, it breaks down into the optical tube that you see right here and the base, which also has the mount that the telescope tube is attached to. Now, right here is the counterweight that helps balance out the telescope when I have it tipped over far to one side. This particular scope comes in a variety of different sizes. This, as I mentioned, is an 8-inch. And if you're wondering, what can you see with this particular type of telescope? It comes with a range of eyepieces. I have one in here right now. And to give you an idea of the power and field of view, with this particular telescope, with an 8-inch diameter, with a 10-millimeter eyepiece, I can have a power of 84 and a true field of view, in other words, the actual area of sky that I can see, of about 2/3 of a degree. Now, if I go up to a 20-millimeter eyepiece, the power changes. It drops by almost half, down to 41, but the field of view increases to almost 1 1/4 degrees. So this right here, particular telescope, is both portable, great performance, and at about the beginning of the price point for an advanced observer. Well, from here we're going to step over and go to the scope right here that belongs to Doug Bauer. And Doug, can you tell our viewers a bit about this scope?
Sure, Don. This is a Meade light bridge. It's a Dobsonian telescope, which it rotates, as you can see, on a little platform, and you can tip it up and down, so you can cover the whole sky by adjusting it that way. It's a 16-inch light bridge, which is the biggest light bridge that Meade makes, but Dobsonians come in a variety of different sizes, the mirror size. Mirror sizes, I've seen them as small as 4 inches. I've seen some up to 36 inches, which is a very, very large telescope.
Indeed.
And this one has a truss design to it. These poles here are trusses that hold it. Instead of having a rigid thing like you've got on your scope over here, this is designed to make it lightweight and more portable. So there's 3 of these trusses that you screw into place. So when you're taking this apart to transport it, you can unscrew all of these truss poles and put them in a little bag. This top part up here comes apart, and the lower part with the mirror comes apart.
I see. So you don't have a large, bulky tube
Right.
trying to get it in and out of a vehicle.
Correct, correct. And the other thing, the advantage of this is it doesn't require any power other than a small battery pack to cool the mirrors down. So you don't have to carry a large battery with you. It doesn't have any computer with it. It has some advantages and disadvantages. One thing, it helps you learn the sky, because when you're looking through a scope like this, you have to find everything manually. To do that, on the side of this, we've got a couple of different finders on here. This is what's called a Telrad, and it's a 1 magnification, basically no magnification. You look straight through it, and it projects little big dot circles in the sky, so you can tell where you're pointing really easily by looking from quite a ways away, actually. Then, once you get something sort of centered in that, you go to the finder, which is an 8 by 50 finder that we have on here, and then you see a little bit of a magnified 8-time view of the sky, and you can narrow in even a little closer. Then you'd switch over to the eyepiece here to get the final view of what you're looking at.
Is this a 2-inch eyepiece in this particular scope?
Yes, this is a 2-inch eyepiece. This is a 35mm eyepiece on it. If I had I should say, this scope has a 2500 millimeter focal length. So if, in your case where you were talking about the 10mm eyepiece, with a 10mm eyepiece, you would actually be getting 250 times power. With a 20mm, you get 125 times power. This happens to be a 35mm, so it gives you a little wider view of things, less power. I also have on here a power switch, which has little levers that you can pull in and out that adds an optic in there that acts like a Barlow, which magnifies it a little bit more. So there's 3 different settings on that. So with one eyepiece, you essentially get the equivalent of 3 different eyepieces.
So rather than having that separate Barlow
Right.
tube, you've got it built into this device right here.
Correct, correct. That way you don't have to keep taking the eyepiece out to change the power that you're looking at it. It also has a filter switch built into it, which allows you to snap a filter in like that.
I see.
So if you're looking at a nebula or something like that where you want a different type of filter, it can just snap in. Again, instead of having to screw filters into the eyepiece, you just slide this in, so you don't have to keep removing the eyepiece and putting it back in.
I noticed with this truss tube design, the sides of it are wide open. And most of the telescopes that I see are solid-sided to help keep stray light from getting into the light path. Do you have something to compensate for that on this scope?
Yeah, it's sort of like a convertible top, you know,
All right.
a little rag top that pulls down from the sides and covers, covers the truss. So when you do that, it will keep light from getting into the mirror box, and it has a little Velcro tabs somewhere here that snap on it. So when you do that, it ends up being, you know, pretty completely covered. I put it on kind of loose here, but it does actually stay on.
It does help enclose it to keep the stray light and help with dust and debris from flowing in.
And dew as well at night. If you're observing in a site where there's some heavy dew, this will actually keep the dew off the primary mirror.
Great. All right.
Okay. Is there anything else you think I should cover on this?
I noticed that you've got the secondary mirror right up here. Again, the light travels down the tube, hits the spherical mirror down at the bottom, comes back up to the secondary, and then comes out to the eyepiece, correct?
Right, correct. And with this telescope, like many when you're observing in Michigan, dew is a problem sometimes.
Yes, it is.
So
yes,
actually on this secondary mirror, there's actually a heater wrapped around here. So if it was a heavy dew night, you can plug that in and keep it heated a little bit to keep the dew off it. There also can get heaters for each of these optics as well to keep the dew from blocking your view.
So this telescope is portable because of the truss design.
Correct.
And the performance is great, especially with the diameter.
It's actually very good performance. It gathers a lot of light. It focuses very well. And this is a fairly inexpensive telescope for one of this size. This one, it cost about $1,850 for the telescope, and these are fairly new designs. In the past, these would have been much more expensive, and so it's an opportunity to get something that really gives you good light gathering at a reasonable price.
And light gathering is, of course, very important. The more light you gather, the brighter the image, and the more you can put some magnification.
Correct, and if you're looking at dim objects like galaxies and things, you can actually start to see some of the shape of those galaxies, some of the form of them as well. Where with, say, even a 10-inch, which I have another scope that's a 10-inch, they look more like fuzzy spots. With these, you start to see some of the arms and things in some of the galaxies.
You can resolve more detail in the larger scope.
Correct.
Well, Doug, thank you very much. It's
You're
a
welcome,
really
Don.
very interesting telescope.
You're welcome.
We're going to turn now over here to Ken Anderson. And Ken, I see you have your Canon with you that
Yes.
we refer to it as.
This is my 17.5-inch Discovery Newtonian Dobsonian telescope. Just like Doug's telescope, this is a Newtonian telescope with a large mirror, 17.5 mirror on the bottom. And to address price, price is a function of aperture. And since all of these are kind of Newtonian telescopes, this is the most expensive telescope out here today. And it's about 2.5 times that of a 10-inch Newtonian telescope. To address performance, as you increase in aperture, the amount of stars you see, the individual pinpoints, and the brightness increases. So that's why there's a big push. You have aperture fever, and people want to have bigger and bigger telescopes until they reach their portability limit. This is my portability limit because I can fit it into my Expedition or Navigator. It does split up into 3 pieces. A top piece right here, a bottom piece, which is the heaviest piece, it's about 96 pounds, and the wooden piece. Also, to address portability, I do have wheels which I just added, and it's easy to rotate, and you know, I could pick it up with just one hand and push it out, you know, but it's easy to rotate and move. Now, also, with a size this high, you know, when it's pointing straight up, I do need to have a ladder to get up and look. So here you can see the 17.5-inch mirror.
That's quite a good size there.
Okay, and I'll just step over on this side. So and I do not have any electronics on this telescope at all. So it's just pure out there. I don't have I don't need a shroud because it's a solid tube. I don't really get dew and ice on my primary mirror. Secondary mirror, sometimes I do, but rarely. But I do get dew on my filter slide. I'll just show this. I'll tilt this out a little bit. But I do have filters on here with no filters. The Sky Glow, which is a narrow wideband filter.
That would be to help combat light pollution?
Yeah, and Ultra Block, which is a narrowband filter, and Oxygen 3. And those help see nebulas and planetary nebulas in the light pollution. Mine also has a Telrad finder, and I do have a Telrad finder chart to help me find objects. You can see the little reticle here, so it helps me find objects. And I have a 9x50 other finder, which I don't use. This dews up very quickly. And as far as eyepieces go, I'll talk about the bino viewers a little later. With a 10mm Apostle eyepiece, I get 183 power, 0.29 degrees field of view with a 50-degree apparent field of view eyepiece. With a 20mm eyepiece, I have 91 power, which is exactly half the power, and 0.54 degrees true field of view, also 50 degrees apparent field of view for the Apostle. And this is my widest field eyepiece for a single eyepiece. It's a 2-inch, 40mm Koenig, and I can get 46 power and 1.5 degrees true field of view with a 70-degree apparent field of view.
So this telescope will take both the 1.25" and the 2-inch eyepieces, just like Doug's?
Yes, it will.
All right. I noticed you wanted to talk, you mentioned your bino viewers. It looks like you have a pair of binoculars attached to the side of your telescope. Can you enlighten our viewers about this?
Okay, this is my bino viewers. It's a Dankmeyer binary viewer. It has a 2-inch OCS and 24mm panoptic eyepieces. And I actually have 2 filter switches that I can switch in and out. So there's filters on, there's Barlows on either side. So I have three choices of power times 3 for a total 9 powers with 1 OCS. And I also have a multiplier OCS that I can swap out the front and get even higher power.
The benefit of this device would be you could use 2 eyes instead of 1 to view through a large aperture telescope.
Right. For bright objects, you can actually see a lot more detail with both eyes. With very dim objects, however, sometimes you can't see them with the binary viewers and you need to go to a single eyepiece. Now going to the powers with the regular Newtonian OCS with the original 3 powers, I had 1.4 times, 2.0, and 2.5 times multiplier Barlow powers. With the multiplier, that's putting this OCS on the same 3. I got 1.8, 2.6, and 3.2 powers, with 30% more. And then with the add-on, I have a reducer that brings me down to 1 power, which is basically back to what a single eyepiece would have as a normal power. And I also have the multiplier, so the max end is 3.3. So I have 9 different powers for the same eyepiece with 1 OCS, and with the other OCS I get a total of 18 different powers.
So you've got great performance. Your portability is enhanced by the addition of the wheels and the handles. Did we touch on price, Ken?
As far as price, you do pay for a Dobsonian is the most value telescope for the aperture. Since this is a 17.5-inch mirror, it is the most expensive one out here today. It is about 2.5 times the price of a 10-inch Dobsonian, similar design, just smaller mirror. And that covers it.
All right, good. Well, we hope you've enjoyed this look at equipment for advanced observers. And right after this short public service announcement, we'll be back with a discussion of International Astronomy Day. Don't forget to check out our website. You can see it at the bottom of your screen. Stay tuned. We'll be right back.
You promised me the world. Is this what you had in mind?
Help EarthShare and its members restore balance to the world. Visit earthshare.org and see what you can do. EarthShare, one environment, one simple way to care for it.
Welcome back to our program. Coming up a little bit later this month is International Astronomy Day, one of the biggest days in all of amateur astronomy. And with me here in studio to tell you all about it is John Schroer, a member of the Ford Club. Hi, John. Welcome back to the show.
Well, thank you, Don. It's nice to be here.
Can you fill in our viewers on all the details on this great event coming up later this month?
Sure. International Astronomy Day is sponsored by the Astronomical League, which is a union of astronomy clubs all over the country. It's also being sponsored by Astronomy Magazine and by Celestron, maker of telescopes, who is celebrating their 50th anniversary this year. The Science Center will be hosting the event. It's on Saturday, April 24th. We'll be open from 10 a.m. to 4 p.m. with observing the sun, and we're also in the sky, telescope displays, and more. There are also going to be Astronomy Day events at Kensington Metro Park at the Nature Center. That's for members of the Ford Astronomy Club. Also at the Cranbrook Institute of Science, the Warren Astronomical Society will be hosting an event up there. They'll have their observatory open. And then in the evening of Saturday 24th at Metro Beach Park, there'll be a multi-club event where the public can go out and observe the sky. That is, if the weather cooperates.
Let's hope so. Are there other places that they can go to?
Most certainly. If you go to boonhill.net, that's the homepage for all the astronomy clubs in Michigan. You can find details and other events being held in Grand Rapids, Kalamazoo, Flint, Bay City, and more.
Great. Now, at the Science Center, I know we'll have sidewalk observing for people actually to come up to our telescopes and view sunspots, hopefully, if they're there, correct?
That's correct. We'll also be looking at the crescent moon. Venus will be up in the evening, up in the sky, so we'll be able to show you that during the daytime.
Interesting. And I understand there'll be a drawing again this year for a prize provided by Celestron?
Yeah, Celestron's giving us a 76 millimeter, a very small Dobsonian telescope to give away as a local prize. The national prize of the 30 centers that are hosting this event with Astronomy Magazine include a 6-inch computerized Schmidt Cassegrain telescope. And there's also a bunch of their publications they'll be giving away, like subscriptions to Astronomy Magazine.
Great. Now, with heading out to Island Lake, which is where the Ford Club observes, April 24th is the kickoff for the Beginners Nights.
That's correct. Beginners Night is an event where the public is invited to bring their telescopes and get help from the Ford Club to learn how to use them. We'll help them find ways to improve their usability, their portability, and their performance, and plus help them learn the sky. For people who are shopping for a telescope, it's a great place to go because you can look through many different telescopes and discover which one you might be interested in buying in the future.
That goes back to our program from last month, advice to beginners not to rush out and buy a telescope, but rather look through a number of them and make their decision after that.
Yeah, an informed consumer will get the best bang for their buck when they finally go out and buy their own telescope.
Sounds like a great day. Again, that's Saturday, April 24th?
That's correct.
Great. Well, we hope that all of you can make it to one of these venues either during the day or in the evening on this very important day in amateur astronomy. That's Saturday, April 24th. And right after this brief announcement, we'll show you some upcoming events, astronomy events in our area. Stay tuned. You've just seen a list of some of the upcoming astronomy events in our area. We hope you'll be able to get out and take part in one of these events. With me right now is Steve Whitty, and Steve will tell us what's up in the night sky. Steve?
Thanks, Don. Well, we've just looked at a number of these telescopes. We have, wonderful telescopes to look through. So let's see what we can see with them. In April, well, you don't really need a telescope to see the moon. The moon starts out, April starts out with a full moon because the moon was exactly full on the 30th of March. The phases of the moon in April are more or less on the weekend. So the first weekend, the 6th, has the third quarter, so you can see the moon in the morning. On the 14th, we have the new moon, so you can't see it, but you can see almost everything else in the sky better because there's so much less light. On the 21st, we have the first quarter moon, so you'll see the moon in the early evening. And then on the 28th, we have the full moon, which you can see all night. Now, this full moon is a little larger than your average full moon. The perigee, that is when the moon was the closest to the Earth, happened just a few days earlier on the 24th. The moon can be a little bit bigger or a little bit smaller depending on whether it's closer or farther from the Earth. The difference is about 11%. The beginning of the month, Venus and Mercury are just a little over the horizon, just over where the sun has set. And they're quite close together. They're 3 degrees apart. And that's about, I don't know, maybe 1 or 2 fingers held at arm's length apart from each other in the sky. So they're quite close. Venus is brighter. It may appear bigger in the sky, but both of them are just a dot naked eye. Both Venus and Mercury climb higher, that is, higher from the sun, day to day, until about mid-month. So they get easier and easier. They both get easier and easier to spot because they're higher above the horizon when the sun sets, so the whole sky can get a little darker, and you'll get to see them still before they set too. But at mid-month, Mercury turns around and heads back toward the sun, and in fact it moves so fast that by the end of the month we lose it as an evening object altogether, and it's a morning object. In the early evening, maybe 8 to 9 p.m., the constellation Leo is more or less straight overhead, and to the west in Cancer is Mars. So you'll see Mars. It's pretty bright. It's got a little orange or red hue to it. You can hardly see anything else in Cancer in our light-polluted Detroit skies. So when you see Mars, that's where Cancer is. And then on the other side of Leo, in Virgo to the east, we have Saturn. Now, since Mars was at opposition in January, it has been getting dimmer, and in the meantime, Saturn has been getting brighter, and in fact now Saturn is somewhat brighter than Mars is. In Leo, really by the head of Leo, that's sort of the question mark, or the backwards question mark of Leo, and in fact right near the end star at the top of the question mark, which is Epsilon Leonis, has a great name. Vesta sort of hovers, Vesta, the asteroid Vesta, hovers around. You'll probably need binoculars to spot it, especially in our Detroit skies. So that's pretty much what there is to see. We had a viewer question, and the question was, how come I never see the third quarter moon in the evening? And it's kind of an interesting question. And to answer it, we need to know a little bit about what is going on physically. We've got the sun, we've got the Earth, and the moon orbits in a rotation around the Earth. So let's start the rotation with the new moon. So with the new moon, the moon is between the Earth and the sun. It's very hard to see. It really needs to have orbited a little bit toward first quarter before you can see the crescent moon. And the Earth is rotating in the same direction. So the moon is new, but it's also during the day. So you've got the bright sun there. By the time the moon gets to first quarter, from the Earth you can see half of the moon. So you can see pretty much from the northern hemisphere, you can see the right half of the moon lit up. And that always, always, always happens in the evening because of the way that the Earth is rotating. You've had daylight, and just as it becomes night, you can still see the first quarter moon. By the time you get to the full moon, it turns out, rises just about at sunset and sets just about at sunrise. So you get to see it all night long. And then finally you get to third quarter, which you can only then see in the morning skies. If you've got a question, send us email to astronomyforeveryone@gmail.com. So that's what's up in the night sky. I hope you've enjoyed our program. Let's go out and do some observing.